Hi all. In this video, we will try to understand the terminology from an initial understanding perspective. Let's first differentiate the fact that there are two terms we are dealing with. One is EKS Anywhere, second is EKS Distro. Let's talk about EKS Distro first. EKS Distro, recall in the previous video, I've already mentioned, it's the same distribution that runs inside of the EKS service in AWS Cloud. And now it's open source basically. But essentially, EKS Distro is all about the upstream compliant core Kubernetes stack, plus some of the, and this is unmodified, plus there are some other Kubernetes projects actually that add value to the overall experience of Kubernetes. And in combination, this resembles, or this basically represents EKS Distro. Now to deploy EKS Distro, you could use your own toolkits like KOps and whatnot. But when it comes to deploying on-premises or in vSphere or bare metal environments, either in on-premises or co-located facilities, instead of using your own tools, EKS Anywhere represents a orchestrated build tooling, collection of many different tools, open source projects, to orchestrate the deployment of EKS Distro. Okay, so things like Cluster API, the various command lines from EKSCTL, kubectl, other plugins basically, and some of the CNI and the CSI like Cilium and vSphere CSI and things like that. So there are many different tools that come together to actually deploy EKS Distro and give you that. And in a sense, when we actually, at the fag end of it, basically, this is what is called as an EKS Anywhere cluster. So, for starters or for beginners, don't get confused by, okay, what is EKS Distro and what is EKS Anywhere? It's essentially, you use this to deploy this, right? Now, when you start deploying EKS Anywhere clusters, there are two primary topologies, let's say that, in which you can actually create EKS Anywhere clusters. And it has mostly, there are pros and cons which are actually there on the EKS Anywhere website. And you can simply read about that, which one would be more preferred for your scenario. But essentially speaking, the main difference between both of these is the presence of what we say a dedicated management cluster for this topology, which manages multiple workload clusters. Okay. And in this standalone workload cluster model or topology, you don't have a dedicated management cluster. You can simply create your target workload clusters, as many as possible from the admin machine, actually, a machine where the EKS Anywhere software is running. Likewise here. So you can see the presence of this. Now, what do you mean by a dedicated management cluster as such? So let's talk about vSphere environments, and bare metal is separate, but let's talk about vSphere environments. How would you actually provision these virtual machines? The first question is, when you create a Kubernetes cluster of any kind, you have to start provisioning the virtual machines, right? And then you have to start loading an OS on top of that. Plus then you deploy, the Kubernetes stack on top of that. And all that actually goes on. How do you do all of that? The answer to that is a open source project called as Cluster API. Okay, Cluster API is again, a very opinionated, declarative way of creating virtual machines, let's say, or nodes, and like what Kubernetes is to containers. Cluster API is to virtual machines and nodes and things like that. Cluster API is again open source, and it integrates with many different cloud providers who bring in the infrastructure as a service capabilities, AWS, Google, Azure, and also vSphere. Okay, so there is a vSphere infrastructure as a service provider as a capability set that is consumed by Cluster API. Now, as I said, EKS Anywhere is a build tooling of sorts, right? One of the constituents of that build tooling is Cluster API. So Cluster API, you don't have to deploy Cluster API. You don't have to configure Cluster API and things like that. It's all done through EKS Anywhere under the hood, under the covers. The entire interaction of, so what we do is basically create a YAML template here. Okay, and we supply that YAML template to vSphere seeking these resources to be created or to be scaled or to be deleted, whatever, right? But the request goes to vSphere. Who passes this request to vSphere? How does the resource request model appear in vSphere? All that is basically under the in the premise of or the scope of the cluster API. Okay, so that's one thing to be noted. Now, when you create a cluster, automatically, it will not get created. So first, a Bootstrap cluster inside of this particular administrative machine, a kind Bootstrap cluster is kind of created. Once that cluster is created, inside of that, the cluster API pods, get invoked. The cluster API pods basically get the YAML configuration of the target cluster, and they turn that YAML configuration into resource request to the vSphere environment, and then the cluster is created. Okay. Now I'm going to talk to a little bit more about this, the Bootstrap cluster, and then why there is no presence of a management cluster here, because this management cluster that you see as a dedicated management cluster actually resides inside of the target workload cluster. The management cluster itself represents the EKS controller, the cluster API pods and things like that. Once the cluster is fully created, the cluster API pods that were running inside of this Bootstrap cluster are transferred here through a very orchestrated under the hood tooling. But eventually those cluster API pods, the EKS controller, everything basically comes up here. The machine configurations for all of these machines, the template definitions, the CRDs and everything, they all get transferred from here to here. And then this Bootstrap cluster is killed. Okay, and we'll see this in practicality, but understand that now every workload cluster has a embedded management cluster expressed as a set of pods and CRDs and templates inside of a namespace. So you can think of this management cluster residing inside of a namespace here. Okay. And that namespace components manage the entire Kubernetes cluster. So when you do scaling, when you do upgrades, when you do deletions of the cluster, all that basically expression of that in conjunction with talking to vSphere is done by these management capabilities residing inside of this namespace. Likewise, for this cluster, it has its own management set of capabilities residing inside of the namespace. In this case, you can see that instead of the management cluster residing inside of the, a namespace, it is separated out as a long-lived set of capabilities, as in a dedicated management cluster. So that once you start, your first act will be to build this management cluster, which is essentially nothing but like a standalone workload cluster. There is no difference between this and this, except for the size and the configuration, because this, you might end up in running a lot of workloads here actually, right? And likewise here. In this management cluster, you could bring in a small cluster, which is adequate enough to do what it is intended to do. Okay, which is actually managing creating and managing the life cycle of the end workload clusters. So you don't basically then treat this as a workload cluster, you treat it as a management cluster. So the same process remains the same. The Bootstrap cluster is created here, the management cluster gets created, and then the Bootstrap, the cluster API, the EKS controller, everything resides in the namespace here, but then it also consists of configurations for these end clusters. Okay, as in the machine templates, the the CRDs and everything basically for these clusters are also there residing inside of this namespace. So now when you do a follow-up task after creating a cluster, like a scaling of cluster, okay, so in that scaling of cluster, the kube config, so how do you actually communicate? So the Bootstrap cluster, let's say you issue the commands upgrade cluster. A Bootstrap cluster is created here, okay, in the EKS Anywhere administrative machine. It now talks to this namespaced set of resources. There is an EKS Controller running inside of this. Okay, how does this Bootstrap cluster talk to the EKS Controller here? Through a API basis using the kube config of this cluster. So you say that upgrade this cluster or upgrade this cluster or scale this cluster, scale this cluster. You're actually talking from the Bootstrap cluster when you invoke the whatever upgrade command. And then you actually communicate with this set of pods and controller running here through the kube config of this cluster. That's about it. So for every end cluster, the configuration resides inside of the management cluster. And that's when the changes to be performed are communicated from the Bootstrap cluster to the management cluster. The management cluster will then talk to the vSphere. So when I say management cluster talking to vSphere, it is the same tooling basically. The management, the pods in terms of the EKS controller and the cluster API pods, they issue those config requests to vSphere, taking the end cluster's machine configurations and passing the changes onto vSphere. And then accordingly, the changes are basically performed by vSphere, and then the follow-up tasks are done by so that's essentially how the standalone or the dedicated cluster management model works. Again, I have described this in a set of, you can see it visually here. Step number 1, the kind cluster, the cluster API on the admin machine communicates to vSphere. vSphere creates the standalone cluster. The cluster API resources are shifted here. There is an addition of a EKS controller also loaded here. And then this kind cluster gets deleted, right? And for every standalone cluster creation, the same 4 steps are mainly repeated during the cluster creation process. For cluster changes, the same process happens. Basically, a Bootstrap cluster is created. It basically, instead of now talking directly to vSphere, it will communicate with the EKS controller here. The EKS controller will then talk to vSphere and all. So where I want you to, and likewise, I have the other flow model, which is the dedicated, and I've already spoken about this. So visually, if you want to kind of interpret, what's going on under the hood, that's what things look like actually, right? The benefit here is that, our management cluster capabilities are actually expressed as a long-lived dedicated cluster. The other important thing to note is, when you talk about a standalone workload cluster versus a workload cluster which is managed, the absence of when you inspect the pods in the workload cluster, you will not find any cluster API pods. You will not find any EKS controller pods and the namespaces that actually represent those pods, because all that is living as a dedicated management cluster. In this cluster, when you say get pods, you will see all the cluster API, the EKS controller, everything basically running inside of this namespace. So this, I think, and again, while I have detailed it out at this level, you don't have to worry about it unless you want to get into the technicalities of it. For creating the cluster, it's just a simple set of command. And then, what follows is the type of cluster being created. You just specify. So we have actually created a, sort of a script that is wrapping up the AWS command of EKS, CTL anywhere, cluster, create, and all that into a shell script so that you can offer variables in terms of cluster name, the version of Kubernetes, and it will automatically kind of customize the end template, which is used for the cluster creation, a YAML template, right? But creating an EKS cluster, EKS anywhere cluster is no big deal. It's at most, 10 to 20 minutes of cluster creation process, and in that 15 to 20 minutes, you will have your cluster. If you have been, if you want to execute the creation of this cluster, it will be even less, right? Because there is no presence of a management cluster pod. So this is maybe 5 to 10 minutes. and this kind of cluster will take about 15 to 20 minutes in essence. So that brings us to the close of this video. Hopefully you've got some bit of initial understanding of what are the cluster topologies involved, and as far as the pros and cons go, I would say it's documented, but both of them can apply based on your use case. For example, you want some shared services to be running, you increase the size of the management cluster, and you can actually load up this cluster with several, what we say nowadays is let's say a multi-cluster environment, right? Let's say if you want to run Argo CD or you want to run Cube apps, anything that is multi-cluster and provides for that centralized capability, you can run those services here on the management cluster, so that it can provide for these clusters also as a shared capability, right, from a central management cluster. In this cluster also you can do that, but it's just a topology change here basically, right? Plus some of the shared secrets and things like that, isolation in terms of management capabilities. So all those differences could lead you to this topology versus this topology. Otherwise, you can run this as a production cluster, a full grade production cluster with the biggest configurations, and there will not be any problems actually, right? Yeah. So thanks a lot again. Cheers.